In this video, we are going to talk about section 3.3, derivative of products and quotients. In the past, we learned how to take the derivative in first using the limit definition, f of x plus h minus f of x divided by h, and that took us a while. So the second part was we use a shortcut. We had a power rule where we bring down the power to as a product and then subtract by 1. Now, there are a couple more rules. We are going to be talking about particularly product and the quotient rule this time. So, product rule is the word product means multiplication. So that means a function is written as a two different function being multiplied. And then quotient means division. So you're going to see a function that looks like a division. So the rule is first thing is you have to look at the function and decide if this function is written as two function being multiplied or two function being divided. So you have to identify f and then s, and then to take the derivative of this product, it's this part over here. So product rule is f, and then you take the derivative of a second function, plus now you rotate second function, and then take the derivative of f, the first function. Okay, so you kind of switch the order. So keep the first one, take the derivative of a second one, keep the second function as it is, and then take the derivative of first one and sum that together. Now for the quotient rule looks a little bit more complicated. So you have this numerator and the denominator. And if you take the derivative, you're going to have a bottom one times derivative of a top one minus top one minus the bottom one. So this kind of looks very similar to my product rule, the numerator, except instead of plus, you have a minus all over the bottom square. So the way I remember, because this is a little bit tricky, so this one I say as high term, like a high term, and then this one low term, like a high on the top and then low. So this is how I remember. Low derivative of high, low d high, minus high term derivative of low, low d high minus high d low, all over low square. A little phrase to help me remember the order. So we only have two theorem. All we have to do is identify the function as a multiplication or division and apply it. So we are going to do a bunch of practice. We have 6 problems to practice. Let's begin with the first one. Now take a look at the first one. Obviously, you don't see a division, so you know that it's going to be product. So now my goal is, what is my capital F and then capital S function? So you have to identify. So this to me is a one function, and this to me looks like my other function. So my capital F will be 7x squared, and my S of x will be 3x cubed plus 14x minus 10. Notice I'm rewriting my f of x into capital F, capital S. Now you have the formula, so it's capital F, and then let me put it on the bottom here, and then S prime, which means derivative of a S function, S of x, capital F prime of x. So let's go ahead and have everything ready. Let's take the derivative of capital F. This is an easy one. Bring down the power, subtract by 1. So 42x to the 5th power. S prime will be similar term by term. So you have first one, bring down the subtract by 1, 9x squared plus 14, and then the constant disappear. So we are going to be now plug it into the formula. I'm going to color code it so it's easier. F, and then you have S prime, which is this one. And then you have S function, and then you have F prime. So let's match up the colors. So my derivative function finally looks like capital F, pink one, so 7x6 times the green function 9x squared plus 14 plus 3x cubed, the blue function, plus 14x minus 10 times 42x to the fifth. That's it. But let's take one more step and then simplify. So I'm going to distribute this and then rearrange, combine like terms. So first one, 63x to the 8th plus 7 times 14 will give me 98 x to the 6. Distributing these, I have 42 times 3 gives me 126 x to the x cubed times x to the 5th give me x to the 8th plus 588 distributing x to the 6th minus 420 x to the 5th. I have x to the 8th term that I can combine. So I have 189 x to the 8th. The 6th term, x to the 6th term, combine them together. 686 x to the 6th, and then last term, negative 420 x to the 5th power. That's it. There's your final answer. That's your derivative function for this here. Okay. Let's take a look at our second one. Now, second one, it's obvious. You have a fraction. You have a quotient. So I'll be applying theorem number 2, the quotient rule. So I'm going to actually copy and paste this one so that it's on the same page. I'll take a screenshot and then save image. And then I'm going to put it right over here so that I have the theorem handy right there so I can reference it. So this to me, I'm seeing my numerator. This part over here will be my t of x. My denominator will be my b of x. So let's write it out. So my t of x will be 8/4 root of x. And then my b of x will be x squared plus 4. Now I need to take the derivative for each function. So let's go ahead and do that. Now this one, we can rewrite the 4th root as 1/4. Oops. So it is easier to differentiate, written as a power rule. So we are going to bring down the 1/4 and subtract by negative 4/4. So this one over here, bring down 8 times 1/4. Subtract by 4/4 gives me negative 3/4. So my t prime of x really is 2x negative 3/4. Okay. My b prime of x is easy. That's 2x, and that's it, because 4 is a constant. So let's start color coding. So I will use t of x as a green one, and then this one is a blue one. So right over here, this is where the formula is. Let's zoom in and color code it. So looks like I have a b of x first, low, bottom one, and then t prime of x, which is green one. Okay. Green one over here. And then regular t of x, which is the pink one. And then b prime of x, we use the blue one. And then you have regular b of x, which is the orange one, whole thing square. Okay? So plug it in. Let's plug it in. First one, orange term, right over here. X squared plus 4. Green term, 2x raised to negative 3 over 4. Minus pink term, 8x to the 1/4. This one I can just rewrite it using this. Blue term, which is 2x, all over orange term, x squared plus 4 whole thing square. Okay, now let's do some rearrangement. Distribute this. Distributing the first term, I have 2x to the 5 over 4. Why? Because x to the second power times 2x to the negative 3 over 4. You know that when you multiply, you add the numerator, you add the power. So that will be same thing as 8x negative 3 over 4. So you add that x to the 5 over 4. That's where I got that. This one will give me plus 8, 2 times 4. X to the negative 3 over 4. This one with negative will give me negative 16x. And then you have this 4 over 4, which is 1. So 5 over 4. And then you have the whole bottom, which is x squared plus 4, whole thing square. You can see that these two I can combine because they have a same power. So 2 take away 16 will give me negative 14x to the 5 over 4. And then plus 8x negative 3 over 4, whole thing x squared plus 4, whole thing square. Now at this point, you can FOIL it, or this is perfectly fine, leaving like this. Okay? So the quotient rule requires a little bit more work because it gets messy, but you have the formula. All you have to do is put it into a correct spot. Okay? So let's do a couple more. Number 3. Number 3, you're looking at this and you don't see a division, so obviously you know that this is going to be a product rule. So let's pull out our product rule. So let me erase this one. And then I will copy this. Then put it over here on the side. So I have the rule ready. So you can see that it's pretty obvious that first term will be my f, and then my second thing that is multiplying will be s. So let's find out f prime of x and then s prime of s. And then we start color coding pink term and then green term because s prime. Orange, add orange term times blue term. Okay. So let's write it here. So my f of x is my pink term, 7e to the x. S of x is 7 ln x. F prime of x, this one we did it in chapter last week. Chapter 3.1, 3.2, the exponential and log function. E to the x is just e to the x with the constant there, so it's just 7e to the x. Ln of x, derivative is 1 over x with the constant there, so s prime of x with 7 over x. So now all we have to do is just plug it in, match up the colors. Pink term, which is over here, 7e to the x. Green term, which is this one over here. Let me also do that, and then this will be this one. Green term, 7 over x plus orange, which is right over here, 7 ln x. And then blue term, 7e to the x. Okay, combine like terms and then simplifying. So 7 times 7, which is 49e to the x over x, plus 7 times 7, 49, so 49e to the x ln x will be the final answer. That's it. Okay, so far so good. Just have to keep track of which term and then just match up. Now, remaining one will add a step. So you still have to take the derivative, but they ask you to do more than that. So number 4 is asking you to take f prime of x and then find the equation to the tangent of a graph at x equal 1. So we did a couple tangent problem before. So let's try and then find out the equation for the tangent line. So first, let's begin with taking the derivative, f prime of x. So now you see that this is not a division, so you know that you're gonna have a what? Product rule, right? You don't see a fraction, so there's my product. So again, let's take the first one. You see the two different functions right over here. That's your f. And then this is your s. So s and then f. And then you're going to have f prime of x right over here. And then you're going to have s prime of x right over here. So let's do this one. Let's first take the derivative of f and s. So f of x is 4x squared plus 7. S of s is 2x squared minus 9. So f prime of x will be 8x, and that's it. Because it is constant, right? 7 disappear. Now, for the second one, I have s prime of x, which is bring down the power 4, x, 9 disappear. So my f prime of x tells me pink term right over here, 4x squared plus 7 times orange, let's also color code it. S prime of x will be yellow, and then this one will be green. So I have 4x plus 2x squared minus 9, 8x. Let's distribute, combine like terms. So f prime of x is 16x cubed. This will give me 4 times 7, 28x plus 16x cubed minus 72x. Combining the x cubed term together, I have 32x cubed minus, combining the x term, 44x. Now this will be just first part. We found this, but it's also asking you to find the tangent line. So what does that mean? Going back to what we learned about derivative graphically tells you a slope, right? So this is a slope function. So slope value so that means if I plug it in x equal 1 into a derivative, this means this function is the slope of tangent line to the graph at x equal 1, right? So I'm running out of space, so why don't I add a page, and then I'm going to move this one to the next page, add it over here, number 5, and then go back. I will erase this, and then let's cover it up. Okay, so I'm creating more space. Okay, so let's first find out the slope. So I'm gonna plug it in. So f prime of 1 is 32, 1 cube minus 44 times 1. That's 32 minus 44. So my slope value, in other words, that's your m. 32 minus 44, which is negative 12. Now, we need a whole entire equation, which is y minus y1, point slope from mx minus x1. So I need a point. So I have an x value already. So I need a y value. This time I'm not going to plug it in. I'm not going to plug it into the derivative equation because that's a slope. I'm going to plug it into the original equation, f of 1. So let's see what y value is. So f of 1 is 4, 1 square plus 7, 2, 1 square minus 9. So I have 4 plus 7, 2 minus 9. So I'm having 4 plus 7, which is 11, 2 minus 9, which is negative 7. So negative 77. In other words, our point is 1 comma negative 77. So there's your x value, there's your y value. So we have everything ready. So we have slope m, which is negative 12. That's gonna go here. We have x1, which is my point, x value, and then y, which is right over here. So let's plug it in. Y minus y1, which is negative 77, negative 12, x minus 1. 2 negative makes positive, so y plus 77, negative 12x plus 12. So mx plus b is normally what we want for the equation of a line. So there's your negative 12x, 77, negative 77 add 12, that's gonna give me negative 65. So there's my equation of a tangent line. Okay? So we went further. We didn't stop at derivative. We applied by finding the whole entire equation to the tangent line. Okay, so let's do number 5. This time, same thing. They want you to do some extra work. After you find the derivative, they want you to find the value. They want you to find the x where the derivative function, whole thing is equal to 0. So we are going to set the derivative function equal to 0 and solve for x. This reminds me, I see the fraction, quotient. So I'm going to use a quotient rule right over here. So let's start taking the derivative first. T, my numerator here, and then denominator b. Okay, and then I'll just use t prime as a pink one and then b prime as a orange one. So let's take the derivative for the numerator and the denominator. So t function is 17x. My b function is 5x squared plus 13. T prime, that's an easy one. It's 17. B prime will be, the power comes down, so 10x, and then that's it. So let's color code it so we don't forget. So derivative of a t, I use the pink one. And then b prime, I use the orange one. So let's use the formula and then plug it in, color code it. F prime is blue one first, so 5x squared plus 13. Pink one, 17, minus green one, 17x. B prime, 10x, all over blue term, 5x squared plus 13 squared. Let's keep going distributive. F prime of x will give me 5 times 17, 85x squared. 13 times 17 is 221. This will give me negative 170x squared all over 5x squared plus 13 squared. Let's combine x squared term. So I'm getting negative 85x squared plus 221 over 5x squared plus 13 squared. Now that will be the first part. We are done with taking the derivative. Now the second part is they want you to set up this equal to 0 and solve for x. So let's do that. So if I set the function equal to 0, so that means negative 85x squared plus 221 over 5x squared plus 13 squared equal to 0. Recall that the fraction is only 0 if and only if the numerator equals 0. So I'm really looking for the numerator to equal to 0. When is that going to happen? Well, let's solve. Negative 221, negative 221, negative 85x squared equal negative 221 divided by negative 85. I'm gonna have x squared equal to 221 divided by 85. That is 2.6. It's a square, so I need to get rid of it by taking the square root. So x is equal to plus or minus root 2.6. Or in other words, if you square root 2.6, we get plus or minus 1.612, rounding to the 3 decimal place. Okay. All right. Let's finish the last problem. Now, last problem is an application problem. Okay, so let's take a look there. They ask you to do 3 things. So let's start with part A, move on to B and C. The total sale S in thousand of a video game T months after the game is introduced are given by S of T equal to 125T squared divided by T squared plus 100. Find S prime of T. So that's easy. So let's begin with A, S prime of T. And obviously you can see that this requires a quotient rule because you see a fraction. So again, I'm going to pull my quotient rule over here and then color code it. So I know my color changes all the time. My bottom one, bx here. And then let's use t prime of x green one this time, and then b prime of x pink one. So my t of x My t of x is 125t squared. My b of x is t squared plus 100. So t prime of x, that's easy. So 125 times 2 will give me 250 t. B prime of x will give me 2t. All right. And I'm gonna use t prime. I use a green one. And then b prime, I use pink one. So plug it in into the formula. S prime of t will be blue one, so t squared plus 100. Green one, 250t minus orange, 125t squared. Pink one, 2t all over blue, the bottom one square. Okay. Distributing, to make it simplify, I have 250t cubed plus 250,000t. Distributing with this negative makes negative 250t cubed all over t squared plus 100 squared. T cubed term disappears, so s prime of t, we get 25,000t over t squared plus 100 squared. So that's A, done. Part B asks to find, now notice this one. This first one is no prime, so it's going back to the original function here. Substitute 10. Second one, I'm going to use this one, substitute 10 into a derivative function. We're going to compare these two numbers and write a brief interpretation of what that means. So let's do that. So adding another page. Part B, S of 10, S from this one, I'm plugging it into this. So I have 125 10 squared over 10 squared plus 100. So I get the whole thing as 62.5. S prime of 10, I'm going to plug it into this function here. And then for t, I'm using 10. So 2500010 divided by 10 squared plus 100 squared, which is 6.25. So what does this mean? Well, you can see that, well, first, let's change the unit. Our unit, S, is in 1,000. So really, this is 62. So moving 3 decimal place to the right. 62500. Moving 3 decimal to the right gives me 1236250, right? Because it's in thousands dollar. So that means this over here, S function tells you total sale. So that means the total sale after 10 months are 62,500 games. Now, the derivative function tells you rate of change. So it tells you how fast. So this means sales are increasing at a rate of 62,050 games per month. So that's, these two functions tells you two different information. So let me write it out. The first function tells me the total sale after 10 months are 62,500 games, and sales are increasing at the rate, because derivative function tells you rate, of 6,250 games per month. Okay, so this part over here is this sentence. This one is right over here. Okay. Last one, part C. Use the result from part B to estimate the total sale after 11 months. We did the 10 months, so what happens 11 months? Well, you know that this is 10 months. We know if it's 11 months and we know that it grows by 6,250, I can just add these two, then because this is per month rate, then I'm getting the 11 month. So total sales will increase by approximately 6,250 games during the next month. So we have this 10 months game plus per month rate. So total 68,750 games. Okay. All right, that's it for this videos. Next one, we are going to learn another derivative rule called chain rule, and it has to do with the composition of function.